Hi everyone. So here I've drawn this rather strange looking curve from around here to approximately here. And well, let's call this endpoint B and let's call this endpoint A. Alright, so the concepts of the absolute maximum and the absolute minimum are actually really intuitive. In fact, the absolute minimum, kind of like what it sounds like, is just the minimum value of a function within a given interval. Or if you graph the function, it's the lowest possible point. So here, the absolute minimum is B, because B, within this interval, is the lowest possible point this function can reach. And A is the absolute maximum, or the highest possible value, or the highest possible point. However, I want to show you another graph. So looking at this function, does it have an absolute maximum or an absolute minimum? Interestingly enough, it doesn't. Okay, so you should note that B and A are not defined. They're holes. And for every absolute maximum and every absolute minimum you look at, you should be able to point to a specific value and say, this value is the absolute maximum. Because I can't do that for this function, because B and A are undefined, this function, within this interval, has no absolute maximum and no absolute minimum. Also, you should note that although there's only ever one absolute max and min value, because naturally there's only one highest or lowest value, this value can occur at more than one point. Like at this function, the absolute minimum is at A, B, and C, and the absolute maximum is undefined, or non-existent, because this point here is a jump. Alright. Also, you should note that if a function is continuous on a closed interval, then there must exist an absolute maximum or an absolute minimum, and an absolute minimum. Why is that? Okay, so if a function is defined for its entire interval, or for some interval, then there has to be a highest point and a lowest point. And because it's defined for every point on this interval, these points have to exist. Consequently, there must be an absolute maximum and an absolute minimum, regardless of the strange looking curve I draw. You should note that although there's only ever one absolute maximum value, it can occur at more than one point. You should also remember that if a function is continuous on a closed interval, then there must exist an absolute maximum and an absolute minimum. Although I didn't really discuss this with a graph, the possible location for a max or min is whenever the derivative is 0 undefined, which is also called a critical number, or at the endpoints. However, I think 9 times out of 10, you actually have to test these possible candidates to determine if they're the max or the min. Because what this gives you are just the possible locations for a max or min, and you have to actually test each particular value in order to figure out if they are a max or a min. So thank you. Hope calculus is blessed.